Hello friends, welcome to the session on amplifiers. In this session, we'll be discussing another application of operational amplifier, and this application is called as current to voltage converter using operational amplifier, or IV converter using operational amplifier. In this session, we will see what we mean by current to voltage converter. We will see the circuit diagram and working of current to voltage converter. Also, we will obtain expression for its output voltage. Friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Kanade, and do subscribe to the channel to see many more videos on the subjects of electronics and computer science. So let us start the session with what we mean by current to voltage converter. Friends, we know that operational amplifier is a very versatile circuit, and it is possible to build many more applications by using operational amplifier. We have seen that operational amplifier can be used to build the circuits such as adder, subtractor, integrator, differentiator, comparator. It is also possible that you can build a circuit called as current to voltage converter. Current to voltage converter is an electronic circuit in which the input current is being converted into a proportional output voltage. That is, the output voltage of this circuit is proportional to the input current. This circuit is very useful circuit, and this circuit is used as a transimpedance amplifier. Current to voltage converter is also called as IV converter, and this circuit is being used with the transducers that have current response more linear than that of the voltage response. So there are certain transducers of which the voltage response is poor, but the current response is more linear. And in such a case, we can make the use of IV converter. This circuit can also be used when your measuring instrument is able to measure only voltage and you need to measure the current. So in such measuring instruments, it is necessary to make the use of current to voltage converter. IV converter is a useful circuit in industries as well. You will find that in many industrial process applications, this circuit is being used. By using operational amplifier, we can easily build the circuit of current to voltage converter. As shown in this diagram, the input current is being applied to the inverting input terminal of the operational amplifier. The non-inverting terminal of the operational amplifier is grounded. A feedback resistance RF is connected between the inverting input and output. So this is a simplest form of the circuit which can be used as a current to voltage converter. The input current I in is applied to the inverting input as shown in this diagram. The resistance RF, which is the feedback resistance, is being connected between the output and the inverting input. Such type of the feedback is being called as a negative feedback, and it will control the overall gain of the amplifier. The non-inverting terminal is grounded, and therefore you can say that this circuit is in inverting mode. Now for the purpose of analysis, we will suppose that the voltage at the inverting input is V minus and the voltage at non-inverting input is V plus. Suppose the current that is being flowing through the resistance RF, that is the feedback resistance, is IF. And suppose the input current that is being flowing is the I in. Now we know that whenever we apply some input voltages to the operational amplifier, then operational amplifier will amplify the difference between the two input voltages. And when some part of the output voltage is coupled back to the input, then there is a negative feedback. And because of this negative feedback, we can control the overall gain of the amplifier. Now it is possible that we can obtain the expression for the output voltage of the circuit, and we can prove that this output voltage is proportional to the input current. Now in order to obtain the expression for the output voltage, we will analyze the given circuit. And in order to analyze the given circuit, what we will do is that we will write the Kirchhoff's equation at the non-inverting input. Now we know that the non-inverting input is being grounded, and therefore we can write the Kirchhoff's equation as V plus is equal to 0. That is, the voltage at non-inverting input terminal is equal to 0. Similarly, we can write the Kirchhoff's equation at the inverting input. As shown in this diagram, there are two currents that are meeting at the inverting input, and therefore we can say that the sum of these two currents must be equal to 0. That is, IF plus IIN is equal to 0, where IF is the feedback current and IIN is the input current. Now we can substitute the value of IF. We know that IF is the current that is flowing through the resistance RF. At one end of RF, we have a V minus voltage. At other end of RF, we have a VO voltage. And therefore, we can write IF is equal to V minus minus VO divided by RF plus I is equal to 0. Now we know that in case of operational amplifier, the voltage at inverting input and the voltage at non-inverting input both are same. That is, V plus is equal to V minus, which is equal to 0. Therefore, if we substitute V minus is equal to 0 in the above equation, then we can rewrite the above equation as VO is equal to RF into IIN. That is, we observe that the output voltage is proportional to the input current IIN. That is, the output voltage will change in proportion with the input current IIN. And therefore, we can say that this circuit works as a current to voltage converter. Thank you, friends, for viewing the session. Hopefully, you have understood how this circuit works. Thank you all for viewing the session.